last thing that we are doing is cheating at poker over the phone. So here's where we were at from last time, mathematical poker over the phone. Just a quick review how this actually works. So here's your stuff sending back and forth, right? We've got all these cards. The C sub i's are the values for the cards for I equals 1 to 52. Bob is going to encrypt all of those with his public key, and send those all to Alice. Alice is then going to get all of those. She's going to pick 5 of them to be her hand and encrypt those with her key, send them back to Bob. Bob is going to decrypt those 5, send them back to Alice. She is going to decrypt them, and that's her hand. So she's got her hand, C sub I. The other thing that isn't on here, but that Bob gets his hand right, Alice is going to pick 5 more, send them back to Bob, and he is going to decrypt them, and that will be his hand. So both Alice and Bob will get their hand of cards. We talked through discarding cards last time, so we won't run through these slides. And now we're going to talk about cheating. So in order to cheat at poker over the phone, we need this concept of a quadratic residue. This is a new mathematical concept, quadratic residue. Here's your definition, and I have quadratic residue in the title. That isn't entirely accurate. I should really have quadratic residue mod p. Just like non-trivial square roots mod p, we have to talk about quadratic residues mod p. You can't do it separate from a mod. So R for residue is a quadratic residue mod p if the congruence x squared equal r mod p has a solution. That's your definition. R is a quadratic residue mod p if the congruence x squared equal r mod p has a solution. So here's what we're gonna do. I'm gonna put you into breakout rooms and we're gonna walk through these. For p equals, we're gonna do 11, but let me do one of these first. So let's say that p is equal to 11 and r is equal to 1. I wanna know whether r equals 1 is a quadratic residue or the other term is a non-residue. That's gonna be your other one. So x squared equals 1 mod 11. Is there a value of x in ZP so that this has a solution? Is there a value of x in ZP so that this has a solution? Yes, no? You're nodding, yes, right? So this has a solution. With fingers, you can do this with fingers. If x equals, what's my solution? Thank you, Daniel. The obvious answer would be 1. The other answer would be -1 or 10. So x equals 1 is going to be a solution to this equation. And therefore, we would say r equals 1 is a quadratic residue mod p equals 11. So r equals 1 is a quadratic residue mod p equals 11. Got the basic idea of quadratic residues? You're looking for a solution to this equation? We're good? We could also have said x equals 10 is a solution as well. 10 squared is 100 and 99 is divisible by 11. So 10 squared is congruent to 1 mod 11. That's fine. This equation is always going to have pairs of solutions because if x is a solution, then -x mod p is also going to be a solution. So you only have to find one, but there's always going to be an even number of solutions because they'll come in pairs. Okay, got the idea? Everybody good with the idea? All right, here's what I want you to do then. So p equals 11, I want you to classify the rest of the numbers 2 through 10 as quadratic residues or quadratic non-residues. I'm going to put you into breakout rooms and we are going to do this, give you a couple minutes. It'll probably take 5, 6, 7, somewhere in there. So putting you into breakout rooms, decide whether 2 through 10 are quadratic residues or non-residues mod 11. Everybody clear on what I'm asking you to do? Okay, all right. Rooms should be created and opened now. You should be able to go. So go talk through that.